Hello students, in this video we will practice some questions on the topic laws of motion. This chapter is very important from your exam point of view and has a huge weightage in exams. The following questions are for your practice for the chapter and are in line with the competitive exams. So let's begin with question 1. Question 1 states, a disc of mass 10 grams is kept floating horizontally by throwing 10 marbles per second against it from below. The marbles strike the disc normally and rebound downwards with the same speed. If the marble has a mass of 5 grams each, the velocity with which the marbles are striking the disc is what? Now the mass of disc, that is capital M, is 10 grams and that is given. I can write 10 grams as 0.01 kg, whereas mass of each marble is 5 grams and mass of each marble is given as 0.005 kgs, correct? Suppose the number of marbles striking the disc per second is n and the velocity with which it's striking is v, then weight of disc acting downwards is going to be what? Capital mg, correct? The change in velocity of marbles when they rebound is going to be v minus v, that is nothing but 2v. Therefore, the change in momentum of each marble when it strikes the disc is going to be what? M into 2v, that is 2mv. And total momentum imparted per second to the disc equals to what? 2mv. And this is also equal to the force that is exerted by the marbles in the upward direction. The disc will remain at rest if the net force acting on it is 0, provided it is initially at rest. Therefore, the disc to remain at rest, the weight of the disc should be equal to the upward force that is applied on it. So if I want to write this in form of an equation, I'm going to write that mg equals to 2mnv. Correct? Correct. Next, the weight of the disc should be equal to upward force, as I said, and therefore I wrote that mg should be equal to 2mnv. Where did this n come from? We actually said that n is the total number of marbles that is striking. So this is the total momentum that came out. Alright. So from this equation, v has to be capital mg upon 2mn, and this should be equal to 0.010 into 9.8 upon 2 into 0.005 times 10, and this comes out to be 0.98 meters per second. So 0.98 meters per second is going to be our answer. Next, let's move to question number 2. Question number 2 states, a steel ball of mass 50 grams is thrown vertically downwards with a velocity of 15 meters per second. So this is inverse from a height of 20 meters. It buries itself in the sandy ground to a depth of 20 centimeters. The magnitude of average force exerted on the ball by the sand is nearly what? Assume resistance offered by the sand is constant throughout. So using the equation of motion, that is v square equals to u square plus 2as. So v square will be equal to what? 225 plus 2 into 10 into 20, and this is going to be what? 625. Alright, so v is going to be nothing but 25 meters per second. Again, using the third equation of motion, when the ball finally comes to rest in sandy ground after covering distance of what? 20 centimeter. Let alpha be the deacceleration for the phase of motion in sandy ground. So alpha is the deacceleration that we are assuming. So if I'm going to write down the equation for it, it's going to be what? 0 square equals to 25 square minus 2 times alpha into 0.2, and this is going to be equal to what? 625 minus 0.4 times alpha. and alpha will be what? Alpha will be 1562.5 meter per second square. Now the force acting on the ball are what? mg, and the force exerted by the sand is F. So the force is what? F and mg, correct? So deceleration, that is d, will be equal to what? F minus mg upon m. So this is going to be what? 1562.5, and this has to be equal to F minus 0.5 into, that is upon 0.05. Okay, so when I'm going to solve this, F is going to be what? 78.125 plus 0.5, and I will get what? 78.625 Newton. So the value of F is what? 78.625 Newton. That is option number B. I hope you understood this. Let's move to question 3. Question 3 states, two bodies of masses 5 kgs and 4 kgs are tied to a string as shown in the figure. This is the figure. So this is the block 4 kg, this is 5 kg, this is tension, and this is the downward acceleration. Now if the table and the pulley are smooth, then the acceleration of 5 kg mass is going to be what? So for 5 kg block, the equation is going to be what? It's going to be mg minus t equals to ma, correct? So 5g minus t is going to be what? 5a, alright. And for the 4 kg block, the equation is going to be that t equals to ma, and t actually is going to be what? 4a, because mass is what? Mass is 4. So this is equation 1, and this is going to be equation 2. I'm going to write equation 1 again because I think it's a little bit not understandable. So equation 1 is going to be what? Equation 1 is going to be 5g minus t equals to 5a. So this is equation 1 and this is equation 2. So when I'm going to solve equation 1 and 2, it's going to be a equals to 5g by 9, that is 49 by 9, that is 5.45 meters per second square. So 5.45 meters per second square. Let's move to another question. Question number 4 states that what is the maximum value of force F such that the block shown in the arrangement does not move. So when I'm going to draw the FBD diagram of the block, it's going to be that here it is F cos 60 degree. Downwards it is F sin 60 degree, also mg. This is the force that is applied, and this is the angle theta, alright, and this is the normal reaction. R is the normal reaction. So let F be the maximum value of the force that is applied when the block of mass m, that is under root of 3 kg, does not move on the rough surface. Now R is the normal reaction, that is normal to the surface, or I can say that R is nothing but R is F sin 60 degree plus mg. So F is nothing but force of friction, and mu times R is nothing but F cos 60 degrees. So when I'm going to solve these two equations, then can I write that mu times F sin 60 degrees plus mg is going to be F cos 60 degrees, correct? And when I'm going to solve this equation, I'll get that F is nothing but mu times mg upon cos 60 degrees minus mu times sin 60 degrees. So when I'm going to solve this, it will be that F is nothing, it is 5 upon 1 by 2 minus 1 by 4. And this is going to be what? 20 newtons when I'm going to solve. So the answer is 20 newtons. Let's move on to another question. So the last question of the day says, a block is lying static on the floor. The maximum value of static friction force on the block is what? 10 Newton. If a horizontal force of 6 Newton is applied to the block, what will be the frictional force on the block? Now, as the static frictional force is what? 10 Newtons. Okay. and the body will not move for any force that is less than 10 Newton. Whatever force is applied, if it's less than 10 Newton, then it will be applied to overcome the static frictional force, and that's it. Here, 6 Newton is the force that is applied. So 6 Newton will be the magnitude of the frictional force on the block. This is because as we apply 6 Newton, the block also apply reactional force of 6 Newton, and as an action and reaction are equal and opposite, the block is not going to move. So I hope you were able to digest all of it. Do try solving the test for this chapter on EduRev and check whether you were able to score full or not with complete understanding, of course. Thank you.